collision detection. Basically, the problem is in a video game, you've got two game objects, whatever they are, and you need to tell on the screen if they have collided with each other, like say a projectile and an enemy, or a ball and a paddle, two ships running into each other, or whatever. And the simplest way to do this is to create what's called a bounding box around each object, like a rectangle. A rectangle that circumscribes the smallest region possible that still contains the character, and then you check to see if any of the vertices in either box are inside the vertices of the other, and that's pretty straightforward. But if your objects are round-shaped, like billiard balls, then this starts looking really dumb, because you'll have like the corner of one hitting the corner of the other bounding box, and the two balls that clearly shouldn't be colliding look like they bounce off each other anyway. So you want to treat these as circles instead. And then the question is, well, how do you know if two circles are colliding? Well, that's also pretty straightforward. You take the distance between the centers of the circles, and you see if that's less than the sum of the two radii. You can even use the coordinates of the centers and some trig functions to figure out the angle between them if you want to know like the angle of reflection. Well, that's kind of neat, and that's a pretty simple math problem that can be solved. But we can get more advanced than that, because there's actually a problem here. This works just fine when things are moving slowly, but when they move really fast, there's a bug that will show up where one thing will just pass through the other without colliding at all. And to understand why that's happening, you have to kind of understand a little bit about how video games work programmatically. Basically, a game is organized into frames, kind of like movies. So you have a snapshot where everything in the game is right now. Then you update everything by adding the velocity to the position of all the game objects simultaneously, and then their new positions are your next frame. So if two things kind of pass through each other from one frame to the next, but they don't actually collide in between those two frames, that's especially with fast-moving objects, then this is something you're going to have to deal with. And it's not good enough to detect collisions on each frame. You have to figure out if there will be a mid-frame collision, and if so, where and when that will happen. And how do you do that? Well, there are many methods involving just kind of, one method involves just basic algebra, geometry, and trigonometry. You could make this a calculus problem with related rates, for example, if you gave all objects an acceleration in addition to a velocity. Well, I'll leave that as an exercise to the teacher because it involves a lot of steps, and I'm running out of time here. But I will give a link to a PowerPoint at the end of this presentation, which is I'm almost at, where you can walk through on your own. It kind of breaks down the steps using algebra and a system of parametric equations created by, I didn't actually come up with this. This is another game designer that I'm mercilessly stealing from, but he's awesome all the same. His name is Marc LeBlanc, and he's also a mathematician, I believe, and he put together kind of this thing about high school trig and collision detection. So I hope that that this has kind of given you all a little bit of insight into what some game designers do for a living and how it involves math on a daily basis, even if I've kind of really just scratched the surface here. And by extension, even though this isn't specific to games, I would say in general just keep on the lookout for other fields that use math. And if you can show you how your subject is used in the real world, especially to solve problems that are interesting and meaningful to your students, then you'd be well, I mean, you all already do this, so you understand that you'll be. It's amazing just how much effort they will take to teach themselves advanced topics on their own if they see the value for their time. So here's the some links, and I will type these in to the chat window. So this is a link to the summer course that I gave on game balance last year. It's still out there in blog form, in the form of 10 very long blog posts that you can mine for additional ideas on your own time. Below that this is a link to the PowerPoint that walks you through the collision detection problem that I wish I could take credit for. This is my blog right here, and at the bottom of the screen is all of my contact info. Feel free to email me or look me up or whatever if you have any other questions that occur to you after this is over, and or just my name is relatively unique. I'm not that hard to find. I do not have these slides posted yet. I kind of assumed that these would be that since this is being recorded, that people can just go see the recording. But if you want the slides, Maria, feel free. I know I emailed them to you earlier. Feel free to post them anywhere you want. Um, so with that, I now have some time for some Q&A. If anyone wants to raise their hand or just shout it out, feel free to type into the chat window or just raise the hand or whatever. And other than that, thank you all for coming.
I want to thank, I think we should all give Ian a hand, which is in the little window at the bottom of the screen, because that was fantastic and some fabulous examples. And I just want to remind everybody before anybody takes off that we do have an evaluation for this webinar. So if you liked it, if you'd like to see more, if you'd like to request that Ian do a longer course on this over the summer, I'm not like adding prompts or anything there, then please fill out the evaluation. And in the meantime, if you have questions you'd like to ask, go ahead and put them in the chat window. And those of you who have your hand raised, I'm going to kind of assume if you have your hand raised that you might have a microphone. And if you don't have a microphone, then just go ahead and type your question.
Okay. Yeah, and I don't appear to have any kind of ability to give people rights to talk on the microphone, Maria, so if you can handle that.
Yep.
I will answer Edward's question here. Your son wants to be a game designer. What advice would I give? I could go for a couple hours just talking about that. The fast advice is have him email me. There is another course that I have taught online. The link to that is right there, and that is basically my intro level course in game design. It's 20 lessons. It's completely free other than buying a book. I did write a book on game design, or co-author a book. So that's the one thing that I ask people to buy. But so, not that there's any self-serving nature there, right? But
somebody said the survey was closed. If you could try this link for the evaluation if that's not working.
okay.
And in the meantime, let me see if Edward has a question. I'm going to turn the mic over to Edward. Or maybe he doesn't have a question. He just disappeared.
Oh, I think he is. Is that just the question
Okay.
you were asking before, Edward?
So then I'm going to turn it over to Sandy.
Okay. And then I will answer Scott's question in the thing. But go ahead, Sandy.
Oh, maybe Sandy doesn't have a question either.
Make sure that your microphone is on and unmuted, Sandy. No?
Can somebody verify that that new link for the evaluation is working properly?
And Scott, I would absolutely agree that that mathematics isn't just about computation. I mean, anything that a computer can do is really not something that we want to be training our students to do, because they're just going to be those jobs are gone already. They've been automated. My mathematics training was kind of hit and miss at college. I had the best calculus teacher in the world in high school. I was lucky of that, and so that kind of got me through the first couple of years, because he really went into some of the more advanced stuff and explained it in good ways. Oh. Okay, someone just turned on their mic. Well, getting some echo there. But yeah, I mean, definitely. I'm not sure how much of a help my formal education was. It definitely did teach me a lot of the concepts, but it was kind of left up to me to figure out the application, and that was always very frustrating for me. A great example would be when I did take linear algebra. The course that I took in college was just, we went over all the concepts of it. We learned about matrices. We learned about how to solve them. We learned about eigenvalues and eigenvectors and all sorts of other things. But but we never really learned what the application was. And so me being a kind of jaded college student at the time, just kind of did the minimum in that class to to get my piece of paper. only to run into this little class called computer graphics a couple of years later and realizing, oh, so that's what that's all used for. I wish I had known that. I would have paid more attention. And this has been my frustration, that a lot of my teachers really just kind of went over abstract concepts and didn't really talk about applications. And so I didn't really understand why these courses were required, why they were part of the curriculum, or how I was supposed to use them. That was just kind of left to the student to figure out on their own. So this is why I try to give kind of practical application in my classes whenever possible. Does that answer your question, Scott? Yeah, I think that's definitely true, Robin, that we were never taught these things, and so we kind of have to go out and get them. This is one of the benefits for me of having some game industry experience before I teach game classes. Okay, so I'm looking to see if there are any other questions.
All right, well, I'm not seeing any more questions, and so I really just want to, again, thank Ian for coming. I think it was really enjoyable for everybody and have a breath of fresh applications to our stuff. I can't wait to start using some of this terminology in my classes.
I'm glad this was useful to all of you. Thank you all so much for coming.
And we'll be in touch. So thanks everybody for
Right.
coming today.
Great. I guess you can stop recording now.